discussion session. We invite the Chairman, Organising Committee, International Symposium on Rare Earth, Yang Berbahagia Senior Fellow Academician Dato' Lee Yi Cheong to chair this session. Dipersilakan Yang Berbahagia, Dato'.
Good afternoon. I hope that you all enjoy a good lunch, but not too good as not being able to be attentive for this panel discussion. Actually, I want to postpone the panel discussion because until later, because this morning there was no time for any Q&A. So I want to invite you now. If you have any question on any of the presentation by our four speakers this morning, please ask your questions now. And then later on, then we go into the what called the panel discussion. Is that okay with everybody? Okay. So the first presentation was the keynote address by Mr. Jack Lifton. Is there any question or comments from the floor about his presentation? Before you speak, when you speak, can you let us have your name and affiliation, and also please try to keep your question or comment to not more than 3 minutes. Okay. So anyone want to kick off this afternoon? Dr. McCoy, please.
Hear me?
Yeah.
Jack. Right. I think this is a question not only to the first speaker, but to perhaps the whole panel. Is that okay?
Fine.
Right. I think you should be aware, and I think most of us are aware, those who are sitting at the podium, that our main concern is really about the radioactive waste that comes out of Gebeng. And this is why there have been so many protests about the proposed lamp in Gebeng. And we've had this very bad experience with the Asian Rare Earths enterprise in Bukit Merah, and that was part of the presentation. The problem that we have really in Malaysia is a problem with governance, and we have very little confidence in the way that this company, with its waste problems, will be able to cope in terms of the environment and health issues. The question we are curious about is, why hasn't Lynas built its refinery in Australia? I think we've been given reasons, but the reasons that we feel are valid is that they will not be able to do so in Australia except by following the very strict environmental laws of the country. Whereas in this country, we have a culture of poor maintenance and poor regulation, lack of transparency, and so forth and so forth. So essentially, we think it is a governance problem. And we would like perhaps some of the panel to respond to that.
Dr. McCoy, I think this is the panel discussion. So we will, we will keep this, what you have asked, until a bit later for the answers. So I would just like now to say, any question to the first speakers this morning's discussion? If no, then we pass on to the second.
All right, can I ask you another question then? I was very curious that a group like the Academy of Sciences Malaysia would sponsor a meeting like this, where the emphasis actually is in selling this whole question of rare earths, the rare earths industry. And I would have thought the Academy would have been more interested in the consequences of such an enterprise.
So, any question on the first keynote, the keynote address? If not, then our second speaker was Mr. Alastair New. Any question you would like to raise? Going on. So the third speaker this morning was Professor Dr. Yan from Beijing University, China. Any question or comments about his presentation? Yes, please.
Yeah, hello. My name is Liang, Member of Parliament. My question is, I understand that the extraction of oxide in China, most of them are done in a remote area. But a case like Linus, we have combined extraction and also separation. So if we are talking about a waste of a yearly up to 800,000 meter cube of WLP, so what would be the risk and that your concern? That is my question. Thank you.
Thank you very much for your point. The first point as mine. And I'd like to answer your questions in following points. The first, in China, we want to, because the Chinese city and the towns, they are extension to the suburb area quickly. So that's why the close to the city of the rare earth plants or factories, they are moved or being moved to the suburb or to the mountain or desired areas. And the second thing is for the separation of the rare earths, especially for the monazite. And I think from the point of view of technicals, it's safety. However, the basic considerations is they should take the spatial consideration and take the spatial efforts to meet, to make their emissions meet the requirements and the regulations in Malaysia, as well as in Australia. So the third thing is, normally in China, we will separate the separate the two parts. The first part is mining and pre-treatment of the ores with the separation by the solvent extractions, because they are totally different processing works for the chemical operation units. And the pre-treatment of the ores, they needed to heating and needed a solid reaction between the solids and the liquids. During this processing, they will exposure the gas. For example, the monazite and the bastnasite, they will exposure to the fluoride contain gas. And meanwhile, they also will keep the amount of the solid waste solids contain the contaminants of the thoriums. So that should be separated to the solvent extraction productions. And the fourth is to the global regulations treat the radioactive elements just mentioned by Dr. Christoph, and it's almost the same, even in China and in Malaysia as well as in Europe, right? European countries, it's almost the same regulation or emission standards. So based on the well treatment of the pre-production, I think that all problems the public committee concerned can be solved.
I'm sorry. So that means you do not see any difficulties in handling such a big amount of WLP, like even up to 800,000 meter cube per year?
Yeah. Well, even in the mountain area, it also should meet the requirements of the emission of radioactive elements. No matter city, town, and suburb, and mountain area, it's the same.
So, please.
I'm Teng Bun Sun, Member of Parliament from Tebrau. I would like to draw your attention to the issue which is more concerned by the Malaysian public. The Malaysian public has been overwhelmed by information they have gathered through the TV program, particularly the Phoenix TV program about the aftermath of Fukushima incident, the nuclear reactors leak, and also Bukit Merah's consequences, which has been widely publicized in the papers as to the after effect of the Bukit Merah rare earth processing. My question is, during the processing of rare earth, which stage of processing it is most likable for contamination of a pollution of environment to take place? If it does, how does it take place? And what measure can be taken to prevent such leakage or such contamination or pollution of environment take place during the processing journey? And then we are also aware that what we have learned, what we have heard about the waste produced by nuclear reactors, the volume is small in size. So look like from a layman point of view, it is easier to control. But whereas in the case of Lynas rare earth, the volume is so huge. It is reported in the paper that you need the waste pond to contain the Lynas waste, the rare earth waste, is equal to several football field. It's so huge. So how do you control such a big volume to prevent pollution of environment take place? Thank you.
It's fine.
Please. Yeah.
Well, thank you for your question. And to my experience, the direct answer is everything caused by the Lynas project can be solved if they pay the more and spatial considerations and do well in the future. So that's a direct answer. And for the radioactive contaminants produced during the rare earth separation, it's also suffered not only Malaysia in future, and also for Chinese community. And for example, in Inner Mongolia, that's a quantity of the production is more bigger than the Malaysia Lynas volume in size or in productions. And recently, we also deposit the solid waste to the closed dam, And this dam is constructed by the spatial cement. And also they covered by the soil, and covered the surface is covered by the water. And the water and the soils, the clays, they can protect the wind, bring the dust to out of the dam, right? And this dam have some troubles. The first one is the limited volume or limited capability. And the second is in Mongolia, especially in Baotou, that area, it occurs several times for the very heavy and very strong earthquakes. So during the earthquakes, if the dam be broken, and that will the dust with the water will like the flood with sands to out of the dam, close the dam. So that's why that the Inner Mongolia, they moved the dam, not to move the dam. It's not allow the southwest to deposit continually to the dam. And recently that the production lines is, we take the consideration or efforts, move forward our protection of the environmentals from the post to the pre-stages. That means from the leaching and from the calcination of the ores. And we make all of the rare earths, all of the thorium and other radioactive elements separate from the clay and from the rocks. And that's the final solution.
Maybe Christo, you would like to comment about the the nuclear power waste that was just mentioned.
Maybe just a comment. That's natural occurring radioactivity. We talk about concentration and production, but we have to deal with a lot of amount of waste at the end, and the waste had need a certain control. And from my point of view as a radiation protection man, I know that this control is easy, can be done, but the control must be established. Because there is a hazard. If you concentrate the radioactive material which is coming from the nature, you have to take care about that this radioactive material is not going back to the environment or going to the human beings. But the protection itself, it can be fulfilled. So what you need is a program, a tough program, which is governmental maybe, and from the company as well, to control it. But the controlment is easy, can be done. So that's the thing, the point of view of radiation protection. And I'm not an expert in processing these materials. Maybe we can reduce the huge amount a little bit by pre-concentrate more.
The one thing that I understand about the process in Kuantan is that the waste byproduct ends up with a Becquerel reading very similar to the incoming material from nature. These materials occur all over the place. Malaysia is very well known for tin mining, which has also similar issues. But I think you take a look at Kuantan, they've spent $20 or $30 million just on a waste gas scrubber. In China, you would build an entire rare earth facility for that kind of capital. So I think from what little I've seen and heard, they've put a lot of effort into working on that process, but I agree with Christoph that you have to monitor and make sure that independent people are also involved so that all sides are aware that the information is coming, much like we do in Canada for 43-101. We have independent people involved in producing the 43-101 because you can't have an input just from one side. You need to get involvement from all parties to make sure that the information is reliable but also unbiased.
I think from the questions that's asked from the floor, we have already gone into the panel discussion. So maybe I would just set the stage by saying that the idea of this panel discussion is that the concerned Malaysian stakeholders should have a chance to express their their concerns, their views, so that we can ask our international experts and also some local delegates and participants some discussion, so that the what you call the facts are brought out in the open. So in this process, we actually invited some of the most prominent concerned Malaysians to participate in the panel discussion, but none of them accepted the invitation. So now we are left with the speakers and myself as moderator, and nobody to really itemize the concerns of the Malaysian stakeholder. So Engineer Ahmad, he volunteered to more or less itemize the Malaysian concern. Of course, some of the concerns already expressed by Dr. McCoy and the other speakers of course. So, but I want to give Dr. Ahmad about Engineer Ahmad about 5 minutes, to what you call, to itemize the Malaysian concern. Then after that, I'll open it to the floor. Excuse me, can you allow me to to conduct this meeting?
Before that, I'm also speaking on behalf of the Malaysian people as a member of parliament.
No, please.
Can I complete my question? Because there's only 80% of my question.
Okay.
Just 20%. Can you tell us in a very clear term, all the experts on the stage, when we are talking about Fukushima nuclear reactor leakage, the after effect will last 100 years or even longer than that. That is a layman belief. Can you tell us in a very clear term what are the differences between a nuclear reactor's leakage and the Bukit Merah tin mines radioactive contamination, and also if it does happen in Lina's case, in the rare earth contamination? So what are the differences in terms of consequences, effect to health and environmental issue? Thank you.
Anybody wants? Okay.
So maybe it's related to me, this question. We should totally separate a nuclear power plant from a rare earth facility. What we deal here is just, we have a chemical process. We have a clear input, we have an input of minerals, and we have a separation process. And at the end, we get some residues. And the residues and the storage of the residues need to be controlled. So I think in no stage in a processing plant we have such a huge amount of activity in the concentration that you have really a dangerous by explosion or something like that. But what we have a huge amount of residues which contains higher enriched normal occurring radioactive material. And the difference there is that we have to control the residues. And we have not to focus directly on the contamination area. So that's maybe a totally different thing.
Can I, please, Engineer Ahmad? Yeah.
Dato, moderator, I hope you've seen me standing here.
No, please.
I'm not a member of parliament, I'm just a member of the Malaysian public.
Yeah.
I'm here to ask a question, and I come from Sabah to attend this function.
Please, can I just keep 5 minutes and then you have your chance, please. Okay.
All right. Okay. I hope you're not just giving chances for member of parliament, the ordinary member of the Malaysian public. And I'm not standing here waiting for the train as well.
Okay.
Thank you.
Okay.
Okay. Straight to the point. The time is very short. Basically, I like to, this is through my readings. They are not my opinion, not the opinions of the organization that I represent. Just reading from the press and in internet interaction with the public. So I have summarized it in 36 points. So I have 5 minutes. I'll stop whenever you want me to stop. But I got 36 points. I go in point form to save time. Number one, the public is concerned about AELB to explain what they had approved, and with that approval, what Lynas can do. There's a question being raised by the public, question 1. Issue number 2, about the toll, the temporary operating license. The public, some people say that it was illegal because it contravened the Environment Quality Act 1974. It claimed that no detailed study was conducted prior to the toll being issued for the Lynas plant. The public comment. Number 3, the company is supposed to submit a detailed EIA report to the Director General of Environment Quality. So the question is, when are they going to submit it? The public wants to know. And then number 4, Malaysian government has given 12-year tax holiday. The refinery will generate $1.7 billion a year in exports, equal to nearly 1% of the entire Malaysian economy. The general public wonders, what is the direct financial gain to the Malaysian government? Issue 5. The Lynas project was fast-tracked and approved by the Pahang State DOE within 2 or 3 weeks of submission. To cut it short, the public wonder, without the proper study, detailed study, how come the approval was given? Example, the RIA, radiation impact assessment, was not done yet the approval was given. The build option was given. So the public wants to know, how could the state DOE have approved the PEIA in such a haste? It was done very fast. So this is always being talked about by the public. So they want to listen to the government explanation on that. Issue number 6. DOE is the primary coordinating authority on issues related to the environment and its impact on the well-being of the citizens. The MNA and AELB are promoters of nuclear energy, and this may give rise to conflicts of interest as MNA is the consultant. So the public is concerned about, could there be a possible conflict of interest and control overriding of DOE authority when MNA and AELB is there? The public wants to get clarification. Thus, the question, how independent and autonomous is the DOE? Because of the presence of MNA and AELB. Number 7, what is the RIA, Radiation Impact Assessment, and what was the approval procedure undertaken by AELB? The public wants to know the assessment and the approval procedure. Number 8, which governmental agencies were on the RIA approval panel? Because of transparency, the public wants to know who sits in the panel for RIA, and what are the criteria used by the panel in the assessment of RIA. Why is the RIA or its contents not available for independent experts scrutiny? Public inquire. Then number 9, Lynas is required to apply to the AELB separate licenses for siting, construction, importation, and so on, to cut it short. So what licenses have been approved to Lynas? The public wants to know. Number 10, no cost benefit assessment was performed. Then, if no cost benefit assessment was performed, that people say invalidates the recommended for build option for Lynas, because the study is supposed to include people's health, tourism, fisheries, and other industries. That's 10 issue. Issue 11.
Can
I stop there.
I think as a first segment, okay, because it is 36. Next 36. We can't remember the first, you see. So maybe just the 10.
All right.
Okay.
I stop there. Okay.
So now maybe anyone wants to, please, the speaker who has been standing a long time.
Thank you, Dr. Moderator. I'm not a speaker. I'm just here to answer, to ask or make some comment relating to this issue. My name is Omar Abdul Qadir. I'm here representing Malaysian Environmental NGO, or in short, Mango. And I would like actually, that's why I would like to speak before the gentleman presented those lists of concern. It's actually to Professor Dr. Yan. In his answer earlier to, I think, the YB's question, that if I think I remember, I get you right, that you said that in your Bayan Obo mine in Inner Mongolia, recently you have to shift the waste treatment, and this is bearing in mind that you have been operating since, I believe, in the mid-80s, more than 30 years, and it shows that with the expertise that you all have got and the experience in about 3 decades of operating rare earth processing and mining, you still have problems just recently. So that, I believe, is not assuring to a member of the Malaysian public like myself. You know, it's, and again, the Bayan Obo, you talk about the Bayan Obo mine in Inner Mongolia, I think it's in the public domain that it is found that the incidence of lung cancer among the miners is way above the average, and this is contributed to the inhalation of the dust that is prevalent in the mines. I know we're not talking about mining in Kuantan or Gebeng, but the and this is contributed, I believe, by the thorium that's present in the dust. So the dust that you get from Mount Weld into Gebeng would have, in fact, the data that was presented was 4 times as much the presence of thorium as what is found in the Bayan Obo mine. So that's another big question mark on the health issues, on what could be the consequences of people handling as well as living within that area. So my third comment, I think, was in relation to Mr. McAllister Neil in his presentation, that I think what Linus is going to produce is the light rare earth, which is I believe it's well, I got the notes here, the Syposium, was it? And also the last one, Latinum, yeah, it's cerium and Latinum. And in your presentation that by the year 2015, there will be an oversupply of cerium, and the price as a consequence of that would crash. And the same thing goes with the Latinum, which is a little bit later in the process. I think you put it in the year 2020, which is about 8 years from now. And so these are the 2 products that we're looking at coming from Linus. And according to your presentation, their price would decline rapidly. Are we trying to say that it may suffer the same fate as in the Bukit Merah mine, where they closed because the cost of producing it more than what you can sell? If that's the case, we're going to end up with a white elephant there.
Can you let
All right.
Let me address a couple of your points.
Thank you.
They will process what is basically known as a bastnasite. 50% of what they produce will be cerium, 25% will be lanthanum, but the main products that they will produce will be neodymium and praseodymium, which will go into the magnetic markets, and that is growing on average on demand 15 to 20% per year, basically since its inception in the 1980s. I know every rare earth project that's out there now, people are evaluating the economics, and you can't use today's prices. And I know some of these projects are questionable, but Lynas, as far as I understand, will have taken a realistic approach to pricing, because they've got people involved in their operation from Rhodia, who decades of expertise in selling rare earths around the world. So, you know, they're not going to build a plant to run it for 2 or 3 years. That just doesn't make economic sense. This project has a long-term horizon, as far as I know from the outside looking in. Neodymium and praseodymium will be the materials, as Jack Lifton pointed out, that will drive deposits like Lynas, Molycorp, Bionobo. There's also another segment that will be a leftover material, samarium, europium, gadolinium. Europium is still valuable. The plant in Kuantan is not equipped to process that material, so they will sell that material to other factories that can get the value added out of that, and so there will be some revenue streams there. I think, I'm trying to remember the other part of your question, but sorry, I've forgotten it. But really, the driver for them will be the neodymium and the praseodymium. Cerium and lanthanum, as I said, my experience was it's going to be an oversupply, but it's a question of price. And supply and demand will be balanced by the price. You can't sell cerium long-term at $150 a kilo. At $2, yes, there's a lot more opportunities for it.
I think that actually this is one of the very few really good projects around, because neodymium is definitely the critical rare earth metal by volume. And this will be most likely the largest single neodymium producer in the world. I don't think that this plant alone can keep up with the demand. So it's going to be in a situation where it's always got business. I wouldn't pay any attention to the cerium and lanthanum issue because I thought we said this morning. If I'm predicting neodymium price in the future to be between $80 and $100 a kilo. This plant's going to produce, I don't know what the total efficiency is, but let's say it produces 3,000 or 4,000 tons. That's 4 million kilograms, $100, $400 million a year. And that becomes billions and tens of billions of dollars worth of product. Keep in mind, a rare earth permanent magnet is maybe 30% neodymium, the neodymium iron boron magnet, which means that every ton of neodymium becomes 3 1/3 tons of magnets. So this plant would produce perhaps enough neodymium to make 12,000 tons of magnets. The current global magnet market is 80,000 tons, and it's growing at a very high rate. So I wouldn't worry about what this plant is going to do with it. My concern would be to run it 365 days a year. It's going to be very much in demand.
I would just go back to your concern about cancer risk and lung cancer by mining. So it's not a new issue. It's a very old issue, and it comes from radon and radon decay products. Because if you go in underground mining, you can get a higher radon concentration in air. And if you don't take care about this one, you get cancers. This cancer must not be, can be, but must not be from dust. So that's a well-known problem that we had in Germany as well. And we had the so-called Schneeberg illness, which is coming from uranium mining, underground mining in the 50s, where they did not take care about the radon problem, and we had a lot of people getting cancers and lung cancer from radon. And as you remember my presentation in the German regulation, the radon concentration in underground mining is regulated in Germany, and it must be controlled by personal dose meters just to keep track about the radon exposure to the workers. So there is just, of course, an increase, yeah.
Before I go back to Professor Yan about the waste disposal at Bionoble, living in China and being involved in China for the last 17 years, there's been a tremendous growth in recognition of the environment. 30 years ago, China was trying to develop a business and an economy, and I think most people will agree that certain things were sacrificed 30 years ago for the development of the country. But it now, particularly within a number of the industries, power, rare earths in particular, there's a much more proactive approach to the environment, and I think that's what you're seeing at Bionoble and some of the other places around China, is they're recognizing that you can't sacrifice the health of the people and the environment for the growth of the country to a certain extent, and that's likely, and I'll leave that to Professor Yan to agree or disagree with me.
Yes. I fully agree with the word from the last there, because the problem I just mentioned, China or Chinese still suffered from the environmental effects recently. That problem is caused by the time advancing, because 30 years ago, all Chinese just want to increase the income. They never concern the pollution, never concern the environmental case. However, during the past 30 years, we take the lessons, because during the economic increase, we should take the considerations to pay or to the environmentals. So the level of the emission during the past 30 years also higher and higher. Recently, the standard is almost the same with the European emission standard. However, before that, it's lower than that.
I listened to a presentation by a gentleman by the name of Konstantin Karinopoulos, who is the CEO of Neo Materials, again a company I worked for 9 years, and we had 2 joint ventures in China, one in Shandong province, one in Jiangsu, and the environmental standards that they have to meet in their processing facilities today are tougher than some of the environmental standards that they have to address outside of China. So there is no question China is changing in that regard, but it takes time to turn a super tanker around, and it will take time. The advantage you have here is you can do things right from the start. You don't have to go back and fix it.
Before I give you the floor, can I just answer, I think, Dr. McCoy's questions? He has, asked the questions a long time ago. So I think the question that I can perhaps give some answer to is why the Academy of Sciences Malaysia is having this international symposium that seem to talk about the rare earth industry as a whole, and also about the business prospect. Actually, this symposium, the 4 speakers are speaking to the theme that now it is not about the rare earth mining, This now is a second phase, is a rare earth refining and separation, as was pointed out this morning. So so our international speakers actually are focused on this separation and refining issue, which is the same issue as what is being posed by Linus Gerping. So, and in our panel here, we have Professor Yan, which gave us the Chinese experience on separation and refining, including the radioactive residual problem, the same as what we have from Dr. Wilhelm about the radioactive problem. You see, so I think the academy is in this issue is looking at the whole spectrum of the rare earth, industry, and actually what we recommend to government is what Dr. McCoy is very concerned about. It is that enforcement. That means that the enforcement must not be seen to be now when the issue is hot. It must be from now until the decommissioning of the plant, maybe 20 years from now. But the other issue that Dr. McCoy raised about the governance issue in Malaysia, about lack of confidence about enforcement and all this, I think that is a very valid issue. I would like actually now to get the international speakers to basically talk about the governance issue also in their own country, or what they know of governance issue in relation to rare earth refinery and also separation plants. Okay. Jack, would you like?
In the United States, it's very highly the most highly regulated industry is mining of uranium and rare earths. I think Alistair was exactly right. You're starting in the right place because you have the experience. Quite frank, I always tell people that I'm an excellent business consultant because I've done everything wrong. So whatever you're telling me, I can tell you how it's going to come out. And this is exactly the case with industry. In my own lifetime in America, I have seen unbelievably bad conditions in mining and manufacturing. And this is all gone now. You are benefiting from the experience of the world. China has recognized this huge issue. The United States has recognized this issue, and we need this material. So we're going to do the most we can to make it as safe as possible. I will tell you the truth. I suspect that the area around this plant is safer than the area on the street outside, health-wise. I mean it. You have the average person who's not a specialist does not realize what we live in, the background we live in of chemicals and radiation. In the United States, there's a shutdown uranium mine in Nevada where they advertise, for your health, you can spend an evening in this place and absorb the radon, the good stuff. And the government shut them down. It was so crazy. But we made an example of this place because, for example, in the United States, shipping any of these materials across a state line requires a special license. We have 50 states. If you want to ship from California to New York, it's quite a bit of paper, probably more paper in weight than whatever you're shipping. And everybody is paying attention to this problem. Keep in mind how serious this is. We had an accident in the United States 35 years ago at a reactor called 3 Mile Island. It emitted a tiny amount of radioactive iodine. No one was injured. The health statistics showed no effect, but it was for years they were cleaning up this site. No one was hurt. What I'm saying to you is not that no one was hurt, but that the reaction was so intense, and we learned so much from this stuff. And to hear today, I'm sorry to be blunt, but I always hear this with people. They're talking about 25 and 50 years ago. I'm talking about now. I have seen all of this. This is very clean. And I'm only partially joking. I think if I try and cross the street out here, which I did yesterday, it's much more dangerous than going to Linus plant.
Anyone want to comment? Otherwise, I give the speaker that's been waiting.
Thank you very much for enlightening us with all your experiences as what you were speaking just now concerning the bad times in America. Can you elaborate to us what will be the ideal location to site such a factory or plant? We would like to know that. What will be the distance from the nearest dwelling? We are very concerned. Thank you.
You know, I am not some engineers, so I cannot give you the exact distance between the city or the town or and the factory and the plants. However, when we design factories, we should have such kind of the data. The first one is control of contaminants and residues, as well as the wastewater and the gas. And the second is location and direction, based on the long-term wind in this local. For example, in north of China, most of the days, the wind is from the northwest direction start. And if in the South China, that's from the inverse direction. So the plant never located in the upstream or up direction of the town and the city. And the third is they are residue storage and transportations. And for example, especially for the radioactive contaminant residues, they need the spatial way, not a highway, it's a way, and there's a railway to transportation the residues from the plant to the storage sites. And the last thing is, should balance the worker from their home or from their house by what kind of the transportation tours. For example, by the bicycle, okay, the half hours, 30 minutes is around the 6 to 8 kilometers, or by the bus, the half hour is around the 20 to 30 kilometers. So based on the transportation tours, so balance all of these factors, we can decide what's the location of the factories.
Anyone else want to add?
I think just to reinforce a little bit what I said earlier is, you know, plants that were built during the Industrial Revolution in Great Britain were built to grow the economy, but there was a lot of lack of knowledge at that point in time. I think the advantage you have here with the the past experience in Malaysia with rare earths, you know, the last 20 or 30 years has seen a tremendous improvement in the ability to monitor, measure, detect, and also understand the implications of all of these different materials. So you have the chance to do it right from the start. It's not like going back and retrofitting a previously built facility. If you do it right and you get the right people involved to monitor it and make sure that the equipment is in place, it can operate well. Why it's put in Malaysia as opposed to Australia, that's something you'd have to ask Linus. My feeling is it was, their original plan was to put the plant into China. And then China started putting on export taxes, and there's a 42% cost of shipping stuff out of China, so economically that didn't make sense. My feeling is, and again you'd have to talk to the senior people at Linus, the reason it was put in Malaysia is an economic reason, not an environmental reason. It's here because you have good access to the end-use markets, good transportation, port access, good infrastructure. To try and, I've been to the Mount Weld facility. To try and build the Kuantan facility in Mount Weld would be a nightmare because logistically moving chemicals in and out of there would be extremely difficult. I could be wrong, but my feeling is this was done for economics, a business reason, and Linus would have to confirm or deny that themselves.
Before I give you the floor, I just want to comment on what Engineer Ahmad had just outlined. I think that if we are going to talk about what government has not done, what Malaysian government and all this, I think we are missing the opportunity to have a dialogue with the international speakers, because they do not know all the what you claim that government had not done, the shortcut, because they really do not know. And I do not want, actually, if possible, to avoid Linus making answers, because this is not the forum to to go back to all these old issues, because those issues are, to me, basically Malaysian issues. I'm not saying that they are not of concern, they are of concern. But I think that with the international speakers here, let us raise questions and then say that, what in your own country, what your knowledge of other countries' practice, whether what, our concerns, are actually whether we are meeting up with the international standard or we are below par and all this. Is that fair enough? I think if that's fair enough, please.
Thank you, Mr. Chairman. My name is Chan Chi Kun. I'm an epidemiologist based at University of Malaya. When I was doing my doctoral studies, I spent a summer working at the Massachusetts Cancer Registry, helping to analyze childhood leukemia clusters. Be louder. Okay, my name is Chan Chi Kun. I'm an epidemiologist based at the University of Malaya. And when I was doing my doctoral studies, I spent a summer working at the Massachusetts Cancer Registry, helping to analyze childhood leukemia clusters around the Pilgrim Yankee nuclear power plant in Plymouth, Massachusetts. That was quite a number of years ago. My question is more current. In the last few years, a couple of studies have been published which have revived very dramatically the issue of how safe are the existing safe thresholds as propounded by the International Commission on Radiological Protection. And since we have a German colleague here, I think you're well aware of the KIC study, right? The study commissioned by the German Radiological Protection Agency, acronyms KIKK, right? A study of childhood leukemia cancers, which was a very large study. It was a national case control study, drawing upon the cancer registries throughout the entire unified German nation, and involving all the nuclear power plants in Germany. That study was done in the mid-2005 thereabouts, and subsequently published. One of the articles was in the International Journal of Cancer in 2008. And just January of this year, there was also a French study published, the GeoCap study. A very similar study, again a national case control study, looking at childhood leukemias in France, and again around involving all the nuclear power plants in France. And both studies came up with a finding that there was a doubling of childhood leukemia risk within 5 kilometers of nuclear power plants. And the notable thing about this is that the levels of radiation, measured levels of radiation, were at least 100 times below, 2 to 3 orders of magnitudes below the existing safe thresholds, 1 millisievert per year, for the general public, and by current ICRP recommended norms, 20 millisieverts per year, occupational. In the case of Germany, our colleague indicated it was 6 millisieverts per year, not 20. So there's not much dispute, about this fact, that there's well-documented excess childhood leukemia risk, in the vicinity of nuclear power plants. The question is, what's causing it? Of course, there are various competing theories, about what's causing this doubling, of childhood leukemia risk. One theory, one of the concerns, which was taken up by the UK expert panel theory, was whether the existing ICRP risk models, which are largely calibrated against external irradiation, drawing upon the only large human database from the Hiroshima and Nagasaki atomic bomb blast. So the question was whether that risk model, calibrated against external sources of irradiation, was adequate, for assessing risk, in particular the biokinetics and the microdosimetry, of internal emitters, as Mr. Wilhelm mentioned earlier. So that issue, and of course there are other competing theories, like whether it could be linked to the electromagnetic radiation from high voltage power cables emanating from the nuclear power plants, or whether there might be an infectious agent involved, the Kinlan hypothesis. But in particular, one of the upshots of this concerns was an expert panel convened by the UK government in 2001, when Michael Meacher, he was the Minister of Environment. He was jointly convened between Department of Health and Department of Environment. They met over 3 years, 2001-2004, and eventually issued a report, 2004. To cut it short, the bottom line was that on the matter of health risk from low-level exposure to internal emitters, in other words, particulates, radioactive particulates that get into the human body either through inhalation or ingestion through food or water from contaminated surfaces. There was no consensus on the health risk from low-level exposure to internal emitters. Among the panel members, the opinions ranged from, on the one end, likely adverse effect, but negligible in magnitude, all the way to the other end, where 2 members of the panel insisted that there was biological and epidemiological evidence consistent with an underestimation of risk by at least 100-fold and possibly up to 1,000. So clearly, no consensus among these experts. Now, what I'm curious about is, in your institute, Kuala Institute of Technology, what kind of research is going on internal emitters, right? Second question,
Can you not make a big, long?
Okay, fine. Just 2 minutes here.
Yeah, thank you.
Second question, in this report, by the Academy of Science, on page 30, there's a table there, which indicates, that the level of thorium, in the thorium cake waste from ARE, was 360,000 parts per million, 36% in the thorium cake waste. Now, the current cleanup operations that Mitsubishi is conducting, cutting up the hill in Kledang and dumping it in there, to my understanding, involves the radioactive waste, which are stored at the factory premises. We recall from the court case that happened in the 80s, that there was testimony by Mr. Ng Tong Fu, who was a contractor hired by ARE, who testified under oath that he was hired to carry out indiscriminate dumping of thorium cake waste, which from academic science sources could have is as high as 36% thorium. And Chan Wei-Si, who is the chief editor of Merdeka Review, has done some investigative reporting, went back to Ipoh and actually interviewed Mr. Ng, and has documented, has reported that this dumping was carried out among other places at Lahad, Jelapang, Buntong, Simpang Pulai, which other places? 6 locations, 6 known locations, that's from one contractor. So in other words, In Ipoh, in and around Ipoh, okay, we have a situation, okay, of unknown numbers of indiscriminate dump sites at unknown locations. And with the thorium content up to about 36%, 360,000 ppm. Now I know that Director General AELB is in the audience again, Raja Abdul Aziz. I'd like to pose the question to him, what is AELB doing about this continuing existing problem, okay, in and around Ipoh? Thank you.
Thank you for your questions. There's a lot of stuff for me to take on. And just let me respond on the low dose problem you raised up. And the KIK study what we had in Germany, it was a very big issue. Just for the people who are not informed about that problem in totality, the problem raised up by one nuclear power plant. And in the surrounding of one nuclear power plant, we had 5 children died on cancer. And that's really a hot spot if you think about 5 young children are dying on cancer, because normally cancer is coming for elder people. So that was rising up a big study, and rising up the same problem what we always have in science, and that's a problem that too many people die on cancer. The cancer problem is each 4th of us will die on cancer. That's the European estimation. So that means if we have 25% of us dying on cancer, how many are died on cancer related to radiation? You cannot answer this really, because that's a too few on this 25%. And that was also the problem how we can go on low dose. To answer your questions, there is no answer. You will find scientists who propose that low dose rates will have a higher risk, and you will find science who say, hey, that's a healthy thing to irradiate you. As we already heard here on the podium, there are some people going in a radon inhalation to get rid of a lung problem. So low dose, no dose, what's happened? We only have results in higher dose rates where the people immediately get some illnesses. So that's a problem on low dose. There's no answer. Is low dose more or less dangerous? Sorry.
Anyone want to comment? Yeah.
Thank you, Mr. Chairman. I have this little concern. My name is Ismail Bahari. From what I have observed and listened to the audience, and of course the answer from the panel, the question is quite, how do I put it? The statement that they were making, the audience were basically like, the impression that I get, if I'm not familiar with the issues, is that the residues or the waste, if you like, that Linus is producing is going to be similar to, equal to, or higher than the Asian rare earth, Fukushima, or what have you. But I've yet to hear one question from the members of the public. What exactly is the level of activity in that so-called Linus waste or residue? What is that level? Now, if you ask that question, then you ask yourself, okay, let me give you the answer. The answer is about 6 becquerel per gram. Now, how does that relate to the actual risk that we are talking about? Because whenever we talk about risk, we always begin with the source term. So the source term is 6 becquerel per gram. Can I give you an impression of what exactly is that in relation to this? The answer is similar to the beach sand of Kerala, India. This is the beach of Kerala, India. And if you take the average, the level there, the activity concentration of thorium is 6 becquerel per gram. You look at the whole stretch of the beach, now you look at the volume that you were talking about. Where are we there? Are all the Kerala Indians, what are they facing? A normally high concentration of mutations? What are we looking at? So I think it's very important for the public and for all of us to ask that question first. What activity are we talking about? What is that source term? Now, until and unless we get an answer, and then we can talk about how far you want to go, how you're going to build the plant, how you're going to process the plant. That's the question that we should be asking. Okay. Now, I like the next issue that I'd like to raise is this question of whether or not it is dangerous at low dose and high dose. I think your answer, the panel from Karlsruhe, is very, very accurate. And I like to support that answer because if you look at the literature, if you look at Ramsar, if there are cases where you can say, oh, I find that, you know, places near the nuclear reactor, you've got a high frequency of radiation. But I can also give you an answer that says in Ramsar, Iran, where the dose is 200 times higher than what we are facing now, and the people are there living longer. So are we saying that we all should run to Ramsar, Iran and get ourselves an extra dose of radiation? No, that's not what I'm saying. What I'm saying is that the answer is very simple. What we know and what the expert, the International Commission for Radiological Protection has done is that they sat down among the experts. They gave a value, they gave a limit, and that is the limit that we know and that we are working on, based on not one data, not on one opinion, but a cumulative, a compound of opinion supporting, against, or neutral. So I think the public must realize that. And I think the other question is, I was quite surprised with the gentleman there, forgot, my apology, I can't remember your name. And you say that you got 36, I managed to only listen a few, but I was sad actually to hear coming from you. You know, saying that the Atomic Energy Licensing Board is a promoter. I mean, come on. The Atomic Energy, I'm sure it's not, but I mean, you can tell the public, it's quite obvious. They are the regulators. Regulators do not promote. I mean, that is so simple to answer. So I think we should not...
Can you...
Sorry, okay, thank you. So I think what I'd like to share with the public is that, I mean, the panel, if you can help me answer this question, is that I think being in this business, yeah, the public concern is real. But I think what you all should also advise the public is that ask that first question. What is the source term? What is the process? How is it carried out? Let me take a look at the text and the document and then make an informed and correct judgment. Thank you.
Yeah. Thank you. Yeah, one very short comment to the last speaker about regulators and promotion. The IAEA regulates nuclear energy, and it also promotes nuclear energy. So there is such a thing as regulating and promoting. Now, I think there are so many uncertainties, as we are beginning to realize at this meeting and even before this, about radiation and about risks, industrial risks from various sources. But I think when there are so many uncertainties, especially when you come to this whole question of radiation with terrible effects of cancer, etc., we ought to observe perhaps two principles which I think are very useful. And the first one is the Hippocratic principle, is first do no harm. I think that's essential, not only in medicine, but I think even in politics. First do no harm. And the other principle is the precautionary principle, which is what we are not following. And if we are so uncertain about these risks, environmental and health risks from radiation, from rare earth industry, then I think we ought to be more cautious about what we're doing. Having said that, can I ask two questions of Professor Yan? Okay. And the first one is, what is your experience, health and environmental problems, as a result of China's very large rare earth industry? That's one. And the second thing, what do you think about recycling waste into fertilizer and building blocks, etc., etc.? This is radioactive waste, recycling of radioactive waste.
Well, thank you. And I try to answer both of your two questions. The first one is, from the statistic or scientific data up to now in China.
I can't hear you, I'm sorry.
Oh, right, sorry.
Can you
okay, thank you for your question. And I try to answer. The first question, the answer of the first question is, up to now in China, we haven't scientific data to relate the cancer with the rare earth industry. It's the first. And the second thing is for cycling off the radioactive residues. It's also our efforts, and we try to concentrate, separate, and purify the radioactive elements from the residues. Then to store it spatially or utilized to the nuclear power requirements?
Just one comment on recycling and using as building material. For me, there's no difference between a recycled material, which is technical enhanced, or normal occurring radioactive material in building material, because the radioactivity in building material should be kept as low as possible and should be kept below regulated values. And if they recycle it to a concrete site and have the same limit as you have it with normal sand, why should they not recycle it? So for me, as limits are below, then it's fine. But it must be controlled. And anyhow.
Can I just make one comment after that, Kumik? We, the ASM, NPC, the study group, one of the recommendations that we make to government is that we must have baseline health study. Because, you know, it's not just about this Linus project. Any actually population anywhere, we must have a baseline health study. And this one, of course, when you are talking about baseline health study, it is long term. So we are recommending to government that it should be independent, not like Ministry of Health. Because Ministry of Health may be just short term, but it should be like university based. So we are hoping that we can get the experience from Institute, from Karlsruhe, in order to help us to set up, you know, what are the requirements of instrumentation and the human capital to have a long-term health baseline study from Malaysia. So I think the Academy of Sciences, our horizon is actually, you know, a bit longer, because you have a lot of debate because we have no data. No data that can actually enable us to form valid, if not a conclusion, at least, you know, some what you call expectations that the way we are going is right. But the other thing about the baseline health study is this, that if you do a study and monitor it over the year, you can find that, you know, all of a sudden something abnormal is happening. And then you are able maybe to take corrective action before the thing, you know, have gone further, and then, you know, cause a lot of problem in the health of the community. So this one, I just want to say that this is one of the recommendations that we are making to government, that very seriously, that we should have a, you know, baseline health study of the population. Okay. Anybody wants to? Yeah, Gumi, please. Sorry.
I thought you were ignoring my hand for a long time. Gurmeet Singh from Saddam. I support wholly your suggestion of epidemiological studies, but I'm very disappointed why we didn't do it since Bukit Merah. By now we should have the results. You know. So this is the problem with us. We keep on wasting opportunities. So I want to take up this issue of monitoring, and I want to ask the panel to give me their feedback on what is the importance of monitoring, and is there any significance in making sure that the monitoring results are made available to the public. I asked that since Bukit Merah days. I've not seen it. So just can I have your comment on that? And I support many of the other comments that have been made about the problems with governance and so on, but let's focus on monitoring and public confidence by making the results public.
Yeah.
Just to answer the German perspective, in Germany, all environmental data which you are collecting must be published. And each people have the right to ask the government for environmental data they have available to give them as public, if it's not published. So that's maybe a way you can go, but that's a German way what we're doing.
And I would agree with that. I think the best way to deal with this is in an open and communicative manner. Anything that is seen to be hidden will always raise suspicion. Whether it's right or wrong, people will question why. So clear and open communication, I think, is the only way that you can go forward. And I'm assuming that that is sort of the standard practice that would happen.
Not here.
Please. Good afternoon, gentlemen and ladies. Yeah. I would like to give a...
Can you tell us who you are?
Yeah, I'm Tengku Arif from USM, University of Science Malaysia.
Thank you.
And I would like to give a small glad tidings to everybody that we had done an epidemiological studies, prevalence studies of cancers around the area of Kuantan. This was asked by AALB in prior of their giving TOL, and we have put up some report to them, which they asked us to. We put up to them before they give the TOL. So at least,
but OSA.
Yeah.
But it's under OSA.
No, it is not. It is not. It is put up. And though a suggestion is that we would after a while, what do you call that, work together with the KIT and the other agencies so that we can bring up what they have done in this.
What is the duration of your study?
Yeah, we took actually the data from the MOH, the Ministry of Health, over a period of 11-12 years, when they had the cancer registry. But we did further on analyzing the data and also in doing surveys on the people around community to see into also some factors related to cancer production. And with this, though it's difficult, it's not easy to pinpoint, hey look, this cancer is due to radiation from whatever sources, because it's a multi-factor disease anyway. But we found that the prevalence, that means the load of cancer, the burden of cancers over in that area is actually comparable with what we have in the whole of Malaysia, and also what we have in other countries, around the region. So
okay, so I give you the floor, but Gumik, I'm sorry, my eyesight is failing, that's why I didn't see your hand being waved. And also that, at my age, my bladder need to be discharged, so can you please just...
Yes, I'll be brief, I promise, Mr. Chairman. Just a couple of very quick responses, to comments from the floor. Most immediately, in the 90s, I did, together with the Penang Department of Health and the National Cancer Society, Penang branch, we did analysis of the completeness of reporting of cancer cases to the National Cancer Registry. Basically, we asked the Ministry of Health for the cancers reported from Penang, and subject to certain case definition criteria. We want to get a sense of how complete were the cancers which were being reported relative to expected numbers. So what we did was we took Singapore cancer incidence rates projected it onto the Penang demographic profile, lagged by 5 to 7 years to account for difference in levels of socioeconomic development. So from there we generated the numbers of expected number of cancers, in the Penang demographic situation, on the assumption that Singapore cancer incidence rates, age-specific, site-specific, gender-specific, race-specific, applied to the Penang population, and then compared that with the actual numbers of cancer cases reported from Penang, turned out to be 1/4. Numbers that were reported from Penang was 1/4 of the expected number of cases. So I don't take very seriously cancer statistics coming up from the National Cancer Registry. I'm sorry, that's the state of our public health statistics quality. With regard to Ismail Bahari's remarks about the levels of radiation in Ramsar, Iran, there's a huge difference between radiation, let's say gamma radiation from geological strata, which might have radioactive elements, embedded in the crystalline structure, of rocks, and radiation, that's from a pile of powdery radioactive waste, which is what, the WLP, the water leach purification waste, from the lamp refinery is going to be in powdery form, which when dry, much of it will be airborne suspendable particulates, and hence inhalable, okay, or ingestible, okay, from contaminated surfaces, okay. Once you get in there, okay, as our German colleague pointed out, okay, it is a completely different ball game, okay, the microdosimetry and biokinetics. Okay. There's a law called inverse square law in physics, applies to gravitation and radiation intensity. Okay. One radioactive particle a meter from your body, okay, there's a certain very low level of intensity of radiation, okay, a meter at your body's surface. Okay. If you inhale it into your body, okay, and now it's down to micron level distances, okay, the intensity of radiation goes up by 1,000,000 squared. Okay. That's 1 trillion times. Thank you.
Just to respond on inhalation or ingestion versus external dose. What I discussed always and what is based in our German regulation is dose level. And dose level by inhalation or ingestion means the 50 years following up dose as you took up the radionuclide. That means we assume that the particle you inhalated or you ingested with your food will stay for the next 50 years in your body, and all the dose, what you get in 50 years, will be stumped for 1 year. So that's a dose model, and that means we take care about that inhalation is totally different, ingestion is totally different from external dose. But we always consume it to dose, not to activity. And that makes dose as risk, and that's okay. But I agree with you, there may be some differences in ingestion and inhalation in the place where the particle are staying. But that's microdosimetry. And we are in the science far away to see that there are differences really in studying. That's a big problem.